Hello, everyone. This is Lynn from HashiCorp. It looks like people are still joining the webinar, so we will start in about 2 minutes. Hello, everyone, and thank you for joining us today for this webinar hosted by our Vault software engineer, Becca, and our Vault product marketing manager, Chris. Today, we'll be discussing how to eliminate secret sprawl in the cloud. I'm going to pass it on to Becca very soon. She'll start by going into an overview of secret sprawl with examples of how companies handle it today and how Vault helps address the security threat of secret sprawl. We'll then spend the last 15 minutes of the webinar dedicated to a case study from Adobe and a live Q&A with the audience. I do want to note that this webinar is recorded and the recording will be made available after post-processing, usually within a day or two. Then I will email it all out to all attendees. With that, we'll go ahead and get started. Becca, take it away.
All right, hi. So my name is Becca Petra, and thank you for joining me for Eliminating Secret Sprawl in the Cloud. I am a software engineer on the Vault ecosystem team, and also at the end, Chris Kent will be talking about an Adobe use case. So here are the sections that we're going to go through today. What is secret sprawl? So we'll define it so that it's easier to talk about it. How does Vault actually address secret sprawl? How does Vault work? So I'm going to give you a real demo of Vault so you can really get your head around the look and feel of the application. And how do you implement Vault organizationally? Like if you wanted to kind of play with it a little bit, how would you do that? And also I'm going to give you some resources for what you can do next if you want to kind of poke around a little bit more. So let's go straight into it. What is secret sprawl? What are we talking about? Well, first of all, let's start by defining a secret. A secret is a credential. It's basically anything that grants you access to a system or authorization within one. So obviously we give out credentials because we want to give access to a specific person and give them specific things that they can do within a system. And so it's important that they don't get out to other people or applications because we're not trying to grant other things access. Like that's the whole point of a credential. So some examples of credentials would be a username and a password that you would use to log into something. TLS certificates, which are used to secure communication between two applications. We just want to make sure only those two applications are talking to each other. API tokens, which are like little keys that servers use to talk to each other so that they can kind of protect data that we don't want to get out to other people. Database credentials would be kind of in the same vein. So if you've got like a MySQL database, for instance, those would be a secret. The credentials to that. And so probably hearing about these secrets, you're wondering, well, can't data be a secret too? Like, what about credit cards and email addresses? And the answer is yes, those are obviously secrets too. And we're going to talk about that a little bit later, but we're going to start off by talking about this first kind of secret that's kind of a good foundation to lay. So what is secret sprawl? Well, first of all, when you start a company or you arrive at a company, your team kind of has to immediately come up with some answers to some questions. How will I share credentials with new people is a big important question. So like you've got a new developer on the team, you've got a new staff member on the team, you've got to give them access to the systems of your organization. How are you going to give them those credentials? What will be the actual way that you do it? And then also, how will I share credentials with automated services? So let's suppose you've got 100 web workers that are serving your website. How are you going to share the credentials to your database with all 100 of those web workers in some sort of automated way? So there are a lot of different ways to answer these questions, and they kind of have to do, the way that people will answer them have to do with the way they've done them in the past and what tools are available to them and what they're comfortable with, And so some examples of how I've seen credentials shared at organizations that I've been at. Some organizations will send passwords and PGP keys through email, which sort of seems fine at first smack, right? Because you're just emailing it from one person to another. But who's logging your email, first of all? And secondly, like email can be forwarded to anywhere. And so then once that email is forwarded to anywhere, like a personal computer that sometimes the person works on, now that password can be retrieved forever into the future. And so that can be a little problematic because, like, let's say the person were to leave the organization, until you remember to actually shut down that password, then they've still got access to a system potentially. Another way that I've seen secrets stored is I've seen them directly in source code. That's not too common most of the time. That's not where secrets go, but there, you know, if a developer is sort of under the gun and doesn't have a better place to put it, then they might just put it straight into the source code. And that's kind of a problem because a lot of the time if someone puts a password in their source code, well, you don't want to push a password up to somewhere like GitHub. So when that happens, a lot of the time the developer will stop pushing up the freshest source code. So you'll end up with old code out remotely for the rest of your team to see, and the actual working code is only on the developer's computer. So that can be a problem. Some people will keep secrets in configuration management tools like Chef or Puppet or Ansible. They'll store credentials somewhere like Amazon S3 or, you know, Amazon Key Value Store, or they could end up in a version control system. And a lot of the time when credentials are being shared in these different places, what happens is that when you spin up a new application, like a new web worker, for instance, it pings these services and pulls it, like kind of comprises a configuration file and pulls it down and puts it on the instance itself. So you've then got a configuration file on the instance that's in plain text, which can be visible to other people who might be able to SSH into the instance or remote into the instance. So they could just go and take a look at the configuration file. And also, you know, if you are storing credentials like in an Amazon S3 bucket, for instance, you can't really control who has access to those credentials in a granular way. So like, for instance, you know, at one organization that I was at, they were all in an S3 bucket and every developer could pull down the S3 bucket and see every secret. And so, yeah, so anyone who can log into these systems can now see these secrets. So even though you might have shared them very intentionally with a certain group, you might be unintentionally sharing them with support and ops and all these different people who you didn't really intend. So what's wrong with this? What if you need to answer the question, who really has access to all of these things? Like, does Becca actually inadvertently have access to these secrets because she can see our logs? It's kind of hard to actually audit who really has access to all of these things, because if they're kind of leaking out here and there and people are picking them up and putting them in email and sending them around or putting them in tickets, you know, you don't really know anymore who has access to all of these secrets. And then even if people have access to secrets now, do we know if they've actually accessed them? Like, just because I, Becca, can see a secret, have I actually gone and taken a look at it? That's kind of important to know. Like, did I look at it and when did I look at it? Especially if you're like tracking a security event later, it's pretty important to be able to track stuff like that. Are these secrets still only in this place? So this is a really good one. So imagine that your ops person who issues MySQL database passwords is out on vacation right now, and you've got a developer who needs to launch a new application. So they're thinking, what am I going to do? What am I going to do? Oh, I know. I can just go in and I can look up the MySQL password that the web workers are using, and I can just put it in my new application, my reporting application. And so now, instead of just the web workers using the secret, now other applications could be using the secret, and you don't really know. And so that creates kind of a problem when it's time to rotate the credentials. So if you decide that for SOC 2 compliance, you're going to be rotating passwords, you know, every 30 days or something, you kind of think about that. Your ops team is going to be thinking really hard about the impacts of that before they do it. And they're going to be thinking, like, do I need a maintenance window? Am I taking down the web workers when I rotate these credentials? And so, you know, then they actually go and they rotate the credentials, but then they don't realize that they accidentally took down the reporting app. when they did it, and they come back up and everything initially looks okay, but then the next day there's a production incident because the reporting app stopped populating data and nobody knows why. And so it becomes like kind of scary to rotate credentials because people are afraid of causing a production incident, of having unintended side effects within the system. And you know, you don't want to be in that position when it's time to rotate credentials. So how does Vault address secret sprawl? So basically, the first way that Vault kind of takes this on is in order to be able to do something, you know, intentional with all of these secrets, we need to kind of centralize them and get them all into the same place. So all of the secrets get centralized into Vault. That's the first step. So Vault runs as basically like a service that other users and services use to get their password. It's middleware. It's an application that's between all the calls from an application to some secure system. And Vault has a really robust API for applications to use to do this in a fully automated fashion. Vault also can be used by users to get secrets as well. But yeah, so the way that it kind of works, the flow, is that now your web worker needs access to MySQL. So instead of just having like the secret stored in its own configuration file, it doesn't. It calls Vault and says, hey, I'm a web worker. I need access to MySQL. Can you give me some credentials? And Vault returns those credentials. So it kind of centralizes everything. And this gives us some really neat properties that we can start adding on. So first of all, I talked earlier about how in most configuration, like in most secret systems, secrets are stored as plain text like this. And so a problem with that is that like if there's a secret up on a screen, anybody who sees the screen could theoretically use it, or anybody who gets access to the plain text secret in a different way could use it, and they don't have to do anything else to use it. They just immediately have it. If they got access to it, it's usable immediately. So in order to prevent that, the first thing that Vault does is it actually encrypts all of the secrets. So, you know, Vault does this invisibly. So when you're actually inside Vault, everything looks like this to you. And when you use the Vault API to get a secret, it looks like this coming back from the API. But when you actually, if you were to open it up and look in the database, this is what you would see. And the way that Vault does this is that it has a secret key of its own that it uses to encrypt secrets. And every Vault implementation has a different secret key. So it's not like the password encrypted is going to look the same across every company's implementation of Vault. It looks different. This particular secret is encrypted using the AES GCM algorithm, but there are different algorithms that you can use here and there in Vault. I'll kind of show that to you a little bit later. But so that's how we kind of protect our secrets inside of Vault. So now that we have like one secret, a key that is being used to protect all of the rest of the secrets, how do we protect that key so that no one person has it and no one person can kind of crack the vault and crack all the secrets, right? So to do that, we use something called Shamir's secret sharing algorithm. This is actually really cool. What it does is it creates this master key for encrypting and decrypting everything. And then Vault breaks that key into 5 pieces using the Shamir secret sharing algorithm. And these 5 keys are called unseal keys. By default, it breaks them into 5, and then you need 3 unseal keys to reconstruct the master key and decrypt the secrets that are inside the vault. So then, basically, once Vault is started, it's in a sealed state, and before any operation can be performed on the Vault, it has to be unsealed. So this is done by providing those unsealed keys. It will show. I'm going to show you this in action during our demo a little bit later. So you may be wondering at this point, like, okay, so where does Vault exactly store these secrets? You actually can kind of choose your own storage engine. One of the cool things about Vault is that it's very pluggable. It's almost like a bunch of Legos that you can kind of put together and build to your business needs. You can store your secrets in Postgres or Cassandra, Azure. We actually support Console, which is a HashiCorp product. And the reason that we support console isn't just because we want you to use our stuff, but it's because since we're also at the same organization as the engineers who work on console, we can kind of work together to make sure that console works really, really well with Vault and that there's a certain synergy there. But you can use whatever you want, and actually to use this to configure a storage engine, there's an interface. So if you want to roll your own storage engine for secrets, or for storing the secrets, you absolutely could. It's actually not that difficult to do. So now that we have encrypted all the secrets and we've gotten them all into Vault, let's talk about how we share them with other people, because that's kind of the point, right? So first of all, you're going to need to be able to get your employees and applications into Vault to see those secrets. So how can you do that? We have different ways that people can authenticate to Vault. One of the ways is issuing them a username and password. But you don't have to do that. It's just there in case you want to. A lot of the time when companies are implementing new systems, people go, oh, great, another system with a new username and password that I have to remember. But you don't actually have to do that with Vault. You can use other ways to authenticate for Vault. So for instance, your developers can authenticate using their GitHub profiles. You can have applications, if you're running on AWS, you can have applications authenticate to Vault using their IAM roles, which is really, really cool. If you, you can authenticate using Google Cloud. LDAP is for Active Directory, so you can use Active Directory with Vault. And there are a variety of other methods, and you can also roll your own too if you have like a custom internal system. So once people do gain access to Vault, however you've decided they should authenticate, the next thing is that you can now add fine-grained access control. So instead of having everybody see every secret that's in there, which is not really desirable, you can make it so they only have access to the secrets that they should see. And the way we do that is with a policy. This is an example. A policy basically grants access to a secret. So inside of Vault, Vault is almost like a file system where you put secrets into folders, or you can put them almost like it's into a particular file. It's not exactly like that, but it's a useful way of thinking about it. So then when you grant access to a secret, you basically just grant access to a path where the secret lives. So that's what you're seeing here. You can see that this policy is granting access to everything under the training _ path. And whoever this policy is applied to can create and read secrets at that particular path. And you can grant access to things at an individual level by putting policies directly on individuals, or you can grant access to things as a group. So then you would create a group like developers, put people into that group, and then everybody in that group has access to a set path. You can do it either way. Another property that you get once you've centralized all of these secrets is an audit trail, which is pretty neat. So out of the box, Vault basically produces audit logs. They're all in a JSON format, which is really cool because that is actually easily consumable by many log aggregators, including ELK, which stands for Elasticsearch, Logstash, and Kibana. It's one that I see used a lot. And so people will use FileBeat to, shoot it off to the ELK stack. But if you don't have a logging aggregator, JSON format is still really useful for just technical people. If you're technical, you can just directly grep the logs and pipe the output to JQ and kind of do it that way. It's pretty handy. If you do use the ELK stack, in Kibana, then you can go and search for, particular secrets to see when it and if it was used and by who and stuff, and using an interface a lot like this. So now we've talked about how to keep secrets encrypted and how to give them to people. And so the next kind of question is like, okay, great. Well, you know what? I gave my secret out, but is it still safe? Like, have you ever had that feeling where like you tell somebody an actual secret and you're like, oh, this is really important, don't tell anybody. But then the next day and the next week and the next month, you're like, is this still a secret? Did you tell anybody? I'm feeling a little uncomfortable. Well, that's probably pretty founded. Like, it's a well-founded suspicion, and it happens with applications too. Applications are actually like really bad at keeping secrets. applications will inadvertently log secrets. Like I've seen applications that log their configuration on startup so that they're easier to debug. And a lot of the time the developers will strip out the passwords, but a lot of the time they'll forget to strip out the passwords. And so then, you know, you've just logged a password to an important application like the database, and then Filebeat picks it up and sends it off to Kibana, and there it is for the whole support team to see forever. You know, or like, what if it gets logged in a stack trace? Like, you know, your application throws an exception and returns it, and that gets logged, and that has the password in it. Or, you know, somebody could be like debugging a memory problem in the app, in their app, and then so they do a memory dump, and they're exploring, hey, what's in memory at the time that this thing happened? Oh, here's the MySQL password. I wasn't supposed to see it, but here it is. And, you know, and then also, like, even further, these kinds of things can get picked up by automated monitoring and sent to somebody through PagerDuty. So now it's like in PagerDuty's logs. So, you know, the sad truth is that, you know, the longer a secret lives, the less we know about where it actually is. So another way of saying this is, like, the longer a secret lives, the more likely it is that it was leaked and that somebody else saw it who wasn't supposed to see it. So how do we deal with this? Like, what are we going to do about the fact that we can't really trust our applications to be good at handling secrets? Well, here's the answer: short-lived credentials. So what exactly is this? So, okay, so Vault basically has this concept of dynamic secrets. And this is a fancy way of saying that the secrets are created when they're actually needed, and then they only are valid for a limited period of time. Vault defaults to having that period of time being just over 30 days. But let me try to explain what this really means. So let's say you've got 30 web workers, and they all need read access to MySQL. So what they do is, it's time to get access to MySQL. They call Vault and they say, what password and username should I use for MySQL? And Vault, at that moment, on demand, creates read-only passwords for MySQL, a read-only password and username. So it might be, the username is instance1234, and the password is ABCD. And that is the short-lived credential that this web worker is going to use, and it's going to expire in 30 days. And then the next web worker calls in, and it gets a totally different username and password that's unique to that instance. So this is kind of cool because it actually makes the machines really easy to tell apart. And there are some side effects of this that are really nice. But let's look at what kind of secret engines we have. We have them for lots of databases. We have them for Active Directory, AWS. You can roll your own secret engine. There are a lot of different options here where we can create dynamic secrets to kind of tighten up the story around who has access to credentials and who's using them and whether they've been leaked. But okay, so the side effect of having unique credentials is that you actually can have a more stable application and have more uptime. To illustrate this, let's suppose you have 6 web servers, and they each have their own unique username and password now because they're using the dynamic secret engine for MySQL. Let's suppose one of them gets compromised and it leaks its credentials. So now you can actually go to MySQL and see that there's like a ton of traffic going on around the password and username that's associated with this particular web worker. You can go into Vault and look up which web worker that is if you want to, and immediately like revoke only that credential. In fact, in Vault, you can revoke credentials at various levels depending on what's needed. But when you revoke a credential for only this one web worker, you take only that one web worker out of commission. So the other 5 web workers stay up and they keep serving traffic for your site. So that's really cool because in the previous world where all 6 of these web workers were sharing the same username and password, if one of them were to get compromised and leak it, you would have to roll it and actually have a short downtime while they all grabbed onto the new password and came back up again. So you can actually have better uptime, and you know, if you have SLAs with customers or whatever, this can help you meet them. So I mentioned earlier that I was going to talk about how we protect this kind of data too. And this is where I do that. So this is not my real credit card information or my real address. The only thing real on here is actually my email address, but it does look like real information. And if you had my real information, I would definitely want you to protect this stuff for me. So how do we do that for this kind of secret? So what Vault can do is help you convert this to encrypted data so that when you're storing it and when it's in transit, it looks like this. We offer encryption as a service using the transit backend. The reason that we offer this is because encryption algorithms can be hard to implement correctly, and it's easy for a developer who's doing it for the first time to make a mistake. And if they do make a mistake, then all of your data is vulnerable. So our encryption is vetted. We know that we've implemented it correctly because our code is open source and subject to both academic and public scrutiny. So you might wonder, how can we take our algorithms that protect these secrets and put them in open source code for everyone to see? Well, it's safe to put encryption algorithms in open source code because they don't rely upon being a secret to work. They rely upon mathematics. So they basically use the power of exponents to make it exponentially difficult to crack a secret, make it take longer to crack a secret than would be practical. Like it could take years to crack a secret, but a secret is only valuable for a much shorter amount of time. And so in addition to being kind of out in public with what our code is, we also are regularly audited to make sure our code is correct. And another benefit to having us do the encryption piece is that you don't have to build your own public key infrastructure or PKI because it's actually really difficult to do. So Vault ends up handling all of that for you and maintaining keys inside itself so that you don't have to worry about it. And so this can be done in the user interface, but we have a full-fledged API, so this can be fully automated. And the way it would basically work is that like your application collects data and it looks like this initially, and then it sends it to the Vault API, and the Vault API returns it encrypted like this, and then it stores it in the database like that. And then later when your application needs it decrypted again, it takes it out of the database looking like this, and then decrypts it and sends it back to your original application that way. I might not have described that flow perfectly. Let me try that again. You have an application that takes it out and it hits the Vault API to decrypt it and gets that back. So it's not Vault that's directly taking it out of the database. We offer encryption as a service so that if you have like a super high load or something and you want to use something else like Hadoop or your own thing for the data, then you can. So the interfaces that encryption as a service offers are or the API methods are basically for encrypting and decrypting and for signing and verifying secrets. So to recap, Vault centrally locates your secrets. It offers fine-grained access control to individuals and groups, provides an audit log, creates unique short-lived secrets, and encrypts sensitive data. Okay, so what I'm going to do now is I'm going to talk briefly about how do we implement Vault in an organization. This section is really short. I know I've done a lot of slides already, and then I'm going to actually give you a Vault demo. So if you want to actually run Vault, you can download our binary from the website, and all you have to do once you've downloaded it is run this command, vault server-dev, and immediately you've got like a dev Vault to play with on your own computer. So that can be kind of fun. And if you were to actually like implement it organizationally, you would want to run it locally or start it on a shared dev server and just let your developers kind of play with it a little bit and kind of get to know it. You would want to answer questions like, who will hold the Shamir keys? How many do we want? You know, how many do we want to unlock the Vault exactly? And then you would want to decide what secrets will live in Vault. Some people start with the most valuable secrets and work their way down. Other people do the easiest secrets to get in and get the harder ones to get in later. And where will the audit logs live and be sent? And, are you going to have just one cluster? Or are you going to have multiple clusters? Because Vault has a really wide range. Like you could run one cluster in GCP and another cluster in Azure and another cluster in AWS. Or you could just have it running on a couple of instances, like a primary one and a fallback one. It's really up to you and your business needs. There's just a really huge range available. And the way that you set up Vault, it does not have to be the way that it always is, because you can add things on. It's like Legos. You can just keep adding on little Legos as you need more pieces. So you don't have to wait until everybody's ready to get in. You can just kind of start with a little bit and then get going. And then someday, if you decide to do a production instance of Vault, you have it set up by an operator with somebody observing them to make sure that they give the keys out and don't record them, and that they revoke the root access token when they're done. And we also have a production hardening guide, that'll give you tips about how to further kind of bolt down Vault. For instance, like, you don't want people to be able to SSH into Vault, because then they could like tamper with the environment in a lot of different and unexpected ways. So anyways, let's get out of the slides and let's talk about how Vault actually works. So I'm going to show you Vault and its actual UI here on my screen. So I'm going to start up Vault here. I'm just running it with a very simple configuration to try it out. And now I'm going to go to the Vault UI right here. So this is what Vault actually looks like when you first start it up. Oh, let me make sure you're able to see my screen. Yeah, okay, we're good. So this is the part where we're going to actually use the Shamir secret sharing algorithm to make a master key and break it into pieces. So I'm going to do the default numbers, 5 key shares, and you need 3 to unlock the vault. I'm going to initialize it right here, and it's like, here are those keys that you should hand out to everybody. I'm going to download them and actually just pull them up right here. Perfect. And I'm going to go ahead and continue to unseal the vault. So I can use any of these 5 keys. These are just 2 different representations of the keys. I can use any 3 of the 5 in order to unseal the vault. So let's try starting with the 4th one. Put it in here. Unseal, awesome. Maybe the first one, how about it? Unseal, and the last one, sure. Unseal, whoops. This is from an earlier session. So when you first unseal the vault, this is what you're gonna see. So now that Vault is unsealed, what we just did is we reconstructed that master key that Vault is going to use to encrypt everything under the hood. And again, when we're in the Vault, everything is going to look unencrypted to us, but under the hood, Vault is encrypting everything invisibly to us. It's doing all that hard work. So now, for the first time set up a Vault, I'm going to use this root token right here. I'm going to go ahead and copy that and use it to log in as an operator. So this is what Vault really looks like when you get into it the first time to set it up. You've got a couple different things here that I want to show you. These secret engines are enabled. A couple secret engines are enabled out of the box. And over here we can see who I'm signed in as. Here we have a break blast procedure. So if we know that the vault has been compromised, we can just seal it at any time, either using this or the API. Everything that you're going to see here can be done via the API. And we've got a little commands line interface here so that people can issue commands to Vault without having to SSH into the instance, which is pretty handy. So we'll kind of get to these other tabs in a moment, but let's kind of create our first secret inside the Vault. So here we go. We're going to go in here and we're going to create a secret. The path for the secret is going to be MySQL, because remember, we kind of think of it almost like a file system here. And let's put some fake creds in here. Username, Biz, and password, Buzz. And we're just going to save it. Boom. So we have a secret in here. It's the MySQL creds. These ones aren't dynamic. I'm just showing you, for the sake of posterity, the key value in engines for the first time. But these can be dynamic too. But anyways, so now we have actually created a secret in here, but we didn't just create it for ourselves. We actually want to share it with people, right? So let's kind of make it so that we can do that. Let's grant somebody access. So I'm going to go in here and I'm going to need a new auth method here to get started. Let's just use username and password and enable the method. Perfect. So now that we've enabled the user pass method, I'm going to add a user to this. What I'm doing here is just copying to my clipboard the command. And so I'm going to use that little command line for this. And what this is doing is adding a user named Becca with a password of foo. So let's hit enter to add me with access to vaults. And great, so now let's actually try out using this username and password in a different tab. So if I go here, I'm going to go ahead and log in, Becca foo, sign in. Great, so now we just saw earlier what Vault looks like to an administrator logging in for the first time, and now we're seeing what Vault looks like to a user with really just basic default permissions for the first time. A user can only see cubbyhole. They have these tabs, but they can't actually do anything with most of these things. Like if they were to try to add a secret engine or an auth method or whatever, they can't actually do it. They do have access to this tool, which is actually really cool. This can be used for like sharing secrets around your organization in a secure way. So for instance, if there were a password that you wanted to email to somebody like this, you can actually go ahead and put it in here and wrap this data, and it'll give you a wrapping token. And you could drop this into Slack, or you could, email it around or share it in whatever way, and some other user could come into Vault or use the API to get this secret out by unwrapping it. So they would just come into Vault, take it, and put it in here and unwrap that data, and there it is. Now, the cool thing about this is that it can only be used once. So let's go away for a second and try to use it again. So yeah, if that got logged somewhere, too bad. It can only be used once, and it was used already. So it's a much more secure way to share secrets around your organization. So right now, this default user cannot see that secret that we just created. So let's make it so that this default user can. I'm going to go over to, here I am already in access. Let's make a group, and the group is going to be developers. And let's give the MySQL policy to this group and just create that group. Great. Okay, so the group doesn't have any members. We need to add Becca to this group. So here I am. And my entity ID is this. So I'm just going to copy that and go back to the group, developers, members. Yeah, let's edit this group and add Becca to this group. Add and save. Okay, let's go back over here and be Becca again instead of an administrator and refresh this page and see if I can see the secret yet. Whoop. I probably typoed something here. Hold on. Let me check my policies again. Oh, I didn't add the policy. That's an important step, isn't it? Okay, let's do that. So I do need to create a policy that's kind of an important piece of that. I'm going to paste that in, and the policy's name is MySQL. And what this policy does is it actually grants access to be able to see the secret. So I'm making it so that the secrets can be listed. And then the only one that I can actually view is the MySQL one. So let's create that policy. And then let's go back to the group and make sure we've applied it correctly. Let's see, policies, MySQL. Okay, let's try again. Let's see how we did here. There we go. Now I can see that. All right, so now Becca can see this secret because I have added myself to the developer group, and the developer group can see the MySQL secret. So boom, there it is. And of course, I would be able to see this via the API as well. So if you wanted to create a group of applications that had access to certain secrets, you could totally do that as well. So that is kind of a high level of that. I wanted to also show you the transit secret engine, because that's the one that you would use for encryption as a service. And so I'm going to go back over here and enable a new engine. We've got this transit secret engine. The reason it's called transit is because it's like secrets in transit. Like you're going to be passing us secrets and we're going to pass them back to you on the way. I don't know if that makes sense to you, but we were kind of thinking of like secrets on the move, if that makes sense. So I'm going to go ahead and enable the transit engine. And so the first thing we need to do is create an encryption key that we're going to use for encrypting a particular type of data. So let's create an encryption key. We're going to call it credit cards. And we have a selection of different algorithms that we can use, you know, depending on our needs and some different configuration options. Let's just create an encryption key. So now we've got one for credit cards that we're going to use for encrypting all of them. And now let's try out using this key right here. So let's put a credit card in here. And yeah, this looks awesome. So what we're going to do is go ahead and encode it and encrypt it. And this is what would be returned by Vault. So you would give it the credit card number and it would give you this. And then this is what you would store inside your own database. And then later, when it was time to actually pull that credit card out again, you would go ahead and take the secret like this, and you would give it to Vault, and Vault would go ahead and turn it back into that for you. And so that, and during this whole process, like the communication between Vault and your application is ideally secured via TLS. That's the way that we intend people to run Vault. And so you've got this secret like protected inside your database. You've got it protected in transit while it's being moved around. And so it's just a really nicely secure way to protect data. And so you would create like a key for different types of data, for instance, like email addresses and home addresses and such as that. So that is it for my demo. That kind of wraps up the content of the webinar. And I just want to thank everybody for attending, and we're going to do a Q&A in just a moment. But if you want to learn more, these are some links that you can go to learn about it and view our code as well. And if you would like to ask questions, if you notice in your widget on the right, there's a little place where you can ask your questions there, and then we'll go ahead and take a look at some of those and answer them for you. So go ahead and start putting them in.
Awesome. Thanks, Becca. Thanks, Chris. So we do have several questions. The first one is, how will web workers or clients prove their identity?
Okay, that's a good question. Yes, so the way that they will prove their identity varies based on how you have set up your vault. So it depends on what you want, basically. Let me go back a couple slides to show you. I'm going to go ahead and let's go back. Sorry, this is pretty fast. But if we go back to this slide right here, there are a variety of different ways that you can prove your identity to Vault. Like, for instance, a lot of people are running web workers in Amazon. And so, you know, a lot of instances get launched into a role, an Amazon IAM role. And so you can set it up so that roles have access to certain secrets in Vault. And so an Amazon IAM role maps to a role in Vault where they should be able to see certain secrets. And so in that example, somebody calls in for Vault access, and a web worker calls in for Vault access, and it says, you know, I'm one of the web workers, I'm part of that role, and then is granted access. And we use that using, we do that using Amazon's Get Caller Identity service. But there are other ways. There's the app role method if you're not using Amazon and you just kind of want to set up apps as roles in advance, and a variety of other ways. You can use identity in Azure or Google Cloud. And I don't want to go too far into depth on those particular methods, but we do have all the docs up on the website, so you can actually go and look at the methods that interest you, and it'll dive really deeply into the technical details of how it's implemented.
Great. The next question is, how is the encryption key protected that Vault itself is using, and where is it stored?
For that question, I'm going to actually turn it over to my colleague, Brian Kassouf, who's on the Vault core engineering team. Brian, do you want to take that one on?
Sure. Hey everyone, I'm Brian. So for the encryption keys that Becca demoed to show the encryption as a service API that Vault offers are protected in the same way that the rest of Vault's data is protected, in that they are stored in Vault's encrypted storage, and that Shamir sharing algorithm that Becca demoed is used to make sure that no one person has all the full encryption keys. And so the Shamir shares come together to form the master key, and then the master key is used to encrypt Vault's keyring, and then the keyring is used to encrypt everything else inside Vault. And so the encryption keys used for transit are also protected by that. And then also our enterprise offering has a number of different ways that you can unseal Vault, which is what we call using the Shamir keys to unlock Vault. And those are using third-party KMS providers. Usually we offer the three major clouds, Azure, GCP, and AWS. And then you can also use HSMs.
And we have time for just one more question. And this question is, do you have, so how do you enable AWS IAM auth method, and does it need root credentials to AWS as well as roles?
Oh, I can answer that one. The IAM auth method is implemented using the get caller identity method that's on the AWS API. And basically the way that it works is the client constructs the get caller identity call that they would send to AWS. And then instead of sending it to AWS, they send it to Vault. And then Vault actually executes the request and receives back the identity of the person of the application that provided the get caller identity call, and then looks inside itself and says, hey, is there a role that's been configured to match this caller's identity, granting it access in Vault? And then based on that, it issues an auth token for it to use to get access to its secrets. So in a way, we're man in the middling the get caller identity call, but we're doing it for good. And get caller identity is actually a pretty secure call. It has a timestamp that's involved inside of its signature. And the timestamp allows the call to be valid for only 5 minutes. And so, yeah, that's basically how it works.
Cool. And we have a lot of really, really great questions. And so I think we have time for one super last question. And after that, we have recorded all the questions and we will send out answers afterwards. So I think for this one, how will a web server authenticate itself against a database? And does Vault add all of those credentials to MySQL database on the fly?
Yeah, it can, definitely. So basically the flow would look like this. Let's say you've got a web server that comes up. It authenticates itself to Vault when it's time for it to get the MySQL password. And then if you're using dynamic secrets, like one of our dynamic secret engines, then right when Vault gets the request for access to MySQL from that particular server, it generates a password, a username and password on the fly, and gives it right back to that application. And that username and password that it's created for it is going to only last for the amount of time that you've configured. So by default, it's 32 days, but it could be an hour, it could be a day, it could be a year, although we would prefer not. And yeah, so it'll return those creds straight to the application, and then the application would use them. And basically, the idea is that the application doesn't store the credentials. Vault is just always running as a centralized service. It's right in the middle of all these calls. And so the application calls, gets the credentials, and then actually uses them to authenticate to MySQL. And then the next time it needs credentials, it either holds on to these ones because, like, in memory, because it knows that they haven't expired yet, or it just keeps calling Vault for the credentials over and over again.
Awesome. That's all the time we have for questions today. Thank you, Becca, Chris, and Brian. I hope everyone enjoyed today's webinar and has a better understanding of how to use Vault to eliminate secret sprawl in the cloud. Thank you for joining again, and a big thank you for everyone for their time today. For more webinars, you can visit our website at hashicorp.com/events. And finally, as I mentioned in the beginning, this webinar was recorded, and we will make the recording available on our website after processing. I will also send an email to everyone who registered with the recording link. We had some requests for presentation slides, so we'll also include those as well as additional answers to some of the questions that we weren't able to get to on this webinar. So keep an eye out on Twitter. I'll post a recording there later today too. And that concludes our webinar. Thank you, everyone, and have a great day.